Alright, in this video we're going to talk about section 6.2, day 1, parabolas. So a parabola is one type of conic section that we're going to be looking at. And a conic section is just the intersection of a plane and a double napped cone. So there's 4 conic sections, and then there's also 3 degenerate conic sections. And on the screen you can see all 7 of those. So working from left to right, if the plane that is intersecting the double napped cone is parallel to the bases, then it's going to give you a circle. Or it could give you a point if it intersects right where the 2 naps of the cone intersects. That would be the first degenerate conic. You can get an ellipse by kind of skewing the plane a little bit and intersecting the cone as you see in the middle, or the second from the left. A parabola is going to intersect through the base, so that's going to be the difference between an ellipse and a parabola. The ellipse is going to intersect just the cone, not the base, and the parabola is going to go through the base of a cone. A hyperbola is going to hit both bases and both cones. And then your degenerate ones, you have the point, which we already talked about, a line, and then 2 intersecting lines. So we've seen parabolas, we've studied parabolas quite a bit, and we usually look at them in the form ax squared plus bx plus c. But we can also define it as a locus of points. So the word locus just means a collection. So how we're going to define parabola is the locus of all points xy in a plane that are equidistant from a fixed line, which we're going to call the directrix, and a fixed point called the focus. And that point is not on the line. So the vertex of the parabola is going to be the midpoint between the focus and the directrix. So down here in the corner, your focus is here, your directrix is here. So the distance from the focus to the vertex is going to be the same as the vertex to the directrix. And then you'll see, by definition, what this means is if you take any point on the curve, so let's take this one here, the distance from the focus to that point is going to be the same as the distance from that point to the directrix. And that's what's going to make this curved section. As we go farther up this way, it's going to drop down. Your distances have to be the same. So, how we're going to write these things in standard form. The standard form is going to have a vertex at hk, and we're going to say it's x minus h quantity squared equals 4p times the quantity y minus k if we have a vertical axis. So if they open up or down like we're used to seeing. And then if it opens left or right, it's going to be y minus k squared, equals 4p times x minus h. Both of those p not equal 0. Now that p, you'll note, is the distance from the focus to the vertex. Now these really shouldn't make, or should make quite a bit of sense as far as the x minus h and y minus k stuff. Because if we think about what this x minus h does to a graph, it moves it h spaces to the right because it's with the x. This y minus k is going to move us k places up because it's with the y. So we're going to go left h and up k. Well, that's going to put our vertex at hk instead of at 0, 0. Your vertical if you have a vertical axis, so something opens like this, your directrix is going to be y equals k minus p. And then if it's a horizontal axis, so it opens up like this, your directrix is going to be x equals h minus p. And that should make sense because your the distance from your focus to your vertex is p. And if this is hk, I have to drop down p, so this would be k minus p would give us this line right here. Also, you'll notice if p is greater than 0, we're going to open up. If p is less than 0, we're going to open down. And again, that should make sense because if we're thinking about something multiplied by the x squared, if this number is negative, we're going to open down. So if p is less than 0, we're going to open down. Same thing with left and right. Right being the positive direction, so if p is greater than 0, we're going to open to the right. If p is less than 0, we're going to open to the left. So let's look at a few examples of how to write these things in standard form. So find the standard equation of the parabola with vertex at the origin and focus to 0. So vertex at the origin tells us that hk is the same thing as 0, 0. So if we just kind of make a rough sketch of this thing, we have our vertex here. Our focus is going to be right here. So if our focus is over here, we know we're going to be opening to the right. So our graph's going to look something like that. So we know we're opening to the right, which means this is going to be in the form y minus k squared equals 4p x minus h. Well, we know h and k are 0 and 0. P, remember, is the distance from the vertex to the focus. Well, the distance here is 2, so we know p is equal to 2. So we can plug this thing in, and we're going to get y squared equals 4 times 2x. So we're going to say y squared equals 8x. And that's going to be the equation of our parabola, y squared equals 8x. Some books, some tests are going to write this with the 8, keep it with the y squared, so they might write it as x equals 1/8 y squared. So depending on the book or the test, it's going to look like one of these two things. Both of them are correct. The reason some books go here is because the x is going to serve as like the y, like if we had y equals x squared, we would keep the numbers with the squared part. So that's just a preference on the author. Both of them are correct. I'll accept either one. So looking at the next example, find the locus of the focus of the parabola given by this thing here. So here's where we're going to take a trip down memory lane. To get the focus, we're going to really need to know what P is. And we're not going to be able to get P from this. We're going to have to put this into the standard form that we saw on the previous page. So what we're going to have to do is we're going to have to complete the square. So we're going to have to complete the square. So if we start with y equals negative 1/2 x squared minus x plus 1/2. The first step in completing the square is we have to get rid of this coefficient. It's got to be 1. So if we multiply everything by negative 2, so negative 2y equals x squared plus 2x minus 1. Then we want to get this 1 to the other side. So negative 2y plus 1 equals x squared plus 2x. Now here's where the completing the square part jumps in. We want to take that 2 and divide it by 2 and then square that answer. What we're going to do with that 1 is we're going to add that to each side. So we're going to get negative 2y plus 1, and we have this new plus 1 equals x squared plus 2x, and then this new plus 1. Now, what we just did is we have now written the right side in such a way that when we factor it, it's always going to be a perfect square. So we need numbers that are going to multiply to 1 but add to 2. Well, that's x plus 1, and x plus 1 gives me x plus 1 squared. And that's going to give us that standard form of the equation. So now we're looking over here, we get negative 2y plus 2. This doesn't look right, because if we look at our standard form, it has to be a number times some parentheses with y. So what we can do here is factor out a negative 2 and make this y minus 1 equals x squared plus 1, x plus 1 quantity squared. Now we're in standard form. So we can find our focus. Remember, the focus is going to be p spots away from the vertex. We know based on this that the vertex, this means shift left 1 and up 1, right? We're going to do the opposite because we're inside parentheses. So our vertex is going to be at negative 1, 1. So if the vertex is at negative 1, 1, we know the focus is going to be p spots away from that. This is going to be an x squared that opens down. So we know it's going to look like this, except shifted. So our focus is going to be down here somewhere. It's going to be p spots away from the vertex. We just have to figure out p. Well, we know that this piece down here, this -2, is equal to 4p based on our standard form. So if we divide that by 2, we're going to get p is -1/2. So from our vertex, we need to go down 1/2 spot. So if we drop down 1/2, that's going to change just the y value. It's not going to affect the x value. So our focus is going to be at -1, and then 1/2 down from 1 is 1/2. So -1, 1/2 is going to be our focus. All right, we have one more example to look at. And it says, find the standard form of the equation of the parabola with vertex 2, 1 and focus 2, 4. So just to kind of take a quick look at which way this thing opens, so we're going to know what our formula should look like. 2, 1's our vertex. 2, 4 is our focus. So we know this thing's going to open this way, which means our equation is going to look like this. Oops, that's y, sorry. Y minus k. So all we need to do is find p, find h and k, and we're going to be good. So h and k are the values of our vertex. So hk is going to be 2, 1. P, remember, is going to be the distance from the vertex to the focus. So if my vertex is here and my focus is here, that distance is going to be 3. So now all we have to do is plug this stuff in. We're going to get x minus 2 quantity squared equals 4 times 3 times y minus 1. 4 times 3 is 12. And we get that. X minus 2 quantity squared equals 12 times the quantity y minus 1. And that's it for standard form. Now, if you wanted to put it into the general form, the ax squared plus bx plus c, all you would have to do is distribute this, divide by 12, add 1, and you'd be in your y equals ax squared plus bx plus c. So, there's a lot going on here, but as long as you keep everything straight, look at this stuff, and just really know what's going on in this box here, you should be okay. So there's a lot going on, but as long as you remember this stuff in this box, you should be alright. So that's going to do it for this video. We'll see you in the next one.